Hello everyone, this is Karthikeyan. I am a candidate master on Code Forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27 and global rank 251 in Google Kickstart Round Day 2021. And today I am going to discuss the problem Chefs in Queue, which was asked in October lunchtime 2013. The difficulty level of the problem is Cakewalk, the prerequisites are stack and modular arithmetic. The number of submissions were 43 in the contest. Let's move on to the problem statement. In this problem, we are given an array A of n integers. We have to find the index of the first smaller element to the right of every index I1, and if that index is I2, then the fear of I1 or the fear of index 1 would be I2 minus I1 plus 1. And if there is no smaller element to the right of index I1, then the fear of I1 would be equal to 1. We have to return the product of all these fear values modulo 1 e power 9 plus 7. So for every index I1, we have to find an index I2 such that I2 is greater than I1 and A of I2 is less than A of I1. So finding the first element towards the right of every index which is having a value smaller than the index. So let's try to find this on the first test case, which is 1, 4, 6, 3 and 2. So it's 1, 4, 6, 3 and 2. Now let's index the elements. First index, second index, third index, fourth index and fifth index. I would iterate from right to left and maintain a stack of indices. Now I would write a dummy code that whenever I am processing the ith element, I would pop from the top of the stack while the stack contain elements, and the index which is at the top of the stack, the value of that index, A of stack.top, is less than or equal to, if the value at the stack.top is greater than or equal to A of I, then I would pop the elements from the stack because these elements cannot act as a small element to me. I would pop the stack. Now after this, if there is an element left in the stack, if the size of the stack is non-zero, then there was an element left which was not greater or equal to the current element. So that is the first element which lies towards the right of me and is having a value smaller than me. So my fear would be equal to the index at the top of the stack is stack.top minus I plus 1. Elsewise, my fear would be equal to 1. So this is the dummy code. After this, I would multiply all the fears and return it modulo 1 e power 9 plus 7. So let's simulate this on this particular test case. First of all, I would just come here, check if this, I would process this element 5, I would process this index 5 and this element 2. Is the stack having any element? I would just come to this loop while the stack.size and A of stack.top is greater or equal to the current element which is having a value of 2. No, the stack is not having any element. So if the stack is having a size, no, there is no element in the stack. So the fear of I would be equal to 1. So the fear of this particular index would be equal to 1. And this particular index would be pushed in the stack. So it is pushed here. Now I would come on this particular index 4. While the stack.size and the A of stack.top, which is A of 5 equal to 2, is greater than or equal to A of 5. Is A of 5 greater than or equal to A of 4? No, this is not the case. So I won't pop the element of the stack. Now, if stack.size, yes, stack contains an element. What is the element? It is having a value of 5. I will just initialize the fear of the index number 4 to stack.top, which is 5 minus 4 plus 1, which is equal to 2. So the fear of this index was 1. Fifth index was fear was 1. The fourth index fear is 2. And after this, I would push the index 4 in the stack. Now I would process the index number 3. It is having a value of 6. I will come in this while loop while the stack is having elements. Yes, the stack is having elements. And the top of the stack is greater than or equal to A of I. Is A of 4 greater than or equal to A of 3? No, definitely not, because it is having a value of 3 and this is having a value of 6. So don't pop the stack. Come here. Does the stack contain some elements? Yes, it does. So what is the element at the top of the stack? 4. So this is the index, so which is having a value which is smaller than me. First index toward the side, which is having the value smaller than index 3. So 4 minus 3 plus 1. The fear of this index would be 2 again. And I would push this current index 3 in the stack. Let's come on this index, which is 2. Now having a value of 4. I will pop the stack till this A of stack to top is having a value greater than or equal to A of I. Is a of 3 greater than or equal to a of 2? Yes. 6 is greater than or equal to 4. Pop it. Is a of 4 greater than or equal to a of 2? 3. Is it greater than or equal to 4? No. Don't pop the stack. Just initialize the fear to 4 minus 2 plus 1, which would be equal to 3. And push the current index in the stack, which is equal to 2. Now come on to the first index, which is having a value of 1. While the stack is not empty and the top element of the stack is greater than or equal to a of I, is a of 2 greater than or equal to a of 1? Yes, pop the stack. Is a of 4 greater than or equal to a of 1? Yes, 3 is greater than or equal to 1. Pop the stack. Is a of 5 greater than or equal to a of 1? Yes, pop the stack. Now the stack does not contain any elements. Is the stack contains any elements? No, it does not contain any element. So the fear of this particular index would be 1. And the answer would be the product of all these fears, which is 3 into 2 into 2, which is equal to 12. So this is a simulation for the first test case. Let's do the same for the second. 4, 5, 9, 8, 2 and 3. Okay. So here are 6 indices: 1, 2, 3, 4, 5 and 6. And the values are 4, 5, 9, 8, 2 and 3. And these are the elements. Sorry. Now these are the indices, these are the elements, and here I would write the fear of each of those indices. The fear of the rightmost element would be 1, because there is no element lying towards the right of me having a value smaller. If there is no element lying towards the right of me, then how can an element have a smaller value? Now I would maintain a stack, push this particular index 6 in the stack. While a stack is not empty and the a of stack.top is greater than or equal to me, now is a of 5 is less than or equal to 6? Yes, pop it. Now stack is empty, push 5. The fear for this particular index would be equal to 1 again. Now come on this particular value. While the top of the stack is greater than or equal to the value at the index which is located at the top of the stack is greater than or equal to the current value, pop the stack. No, it's not greater. Don't pop the stack. So what would be the answer? Stack.top minus this index plus 1. It would be 2. Push the current index, which is having a value of 4. Come on this index. The stack.top having a greater value? No, it is having the index 4, which is having a value 8. Don't do anything. Just initialize the fearfulness equal to 2 and push this index 3. In the same way, come at this index. When you come at this index, which is having a value of 5, you pop the index number 3, you pop the index number 4, you don't pop this index, its fearfulness would be equal to 5 minus 2 plus 1, which is 4. And you push the index with a value index 2. And then you come at the first index. While the stack.top is having a value which is greater or equal, you remove the index, which is the index number 2. Do you remove the index number 5? No, it is having a smaller value. So what would be the fear? 5 minus 1 plus 1, it would be equal to 5. So these are the respective fears of every index, and the answer would be the product of these fears modulo. So 5 into 4, 20, 20 into 4, 80. So the answer would be 80. Now let's move on to my code. So this was the approach, okay. So here is my code. Here n denotes the number of chefs, k denotes basically the seniority of chefs. Answer is initialized with ones. A of I denotes the seniority of the ith chef. I am having a stack. I take the input of the array. I traverse from right to left in the array. While the stack is not empty and the top of the stack is greater than or equal to A of I pop the stack. Now if the stack is having some element, then I multiply that answer with answer into fear of this index, which is equal to stack.top minus I plus 1. After this I push the ith index in the stack. After this I print the answer. And you can see that it is an accepted solution. So if you have any doubts regarding this approach, you can ask in the comment section, and thank you for watching the video.